A boat leaves a dock to cross a river at a bearing of south 68 degrees east. The boat is traveling at 17 miles per hour relative to the water. The river current is flowing due east at 6 miles per hour. We want to find the boat's true speed and bearing, and then there's some rounding directions. Okay, so first of all, let's draw the boat. So off from south, we need to measure 68 degrees to the east. So this angle will be 68 degrees. And there's the vector representing the boat. It's traveling at 17 miles per hour relative to the water, so that's going to be the magnitude of that vector. Then there is the river's current, and that's flowing due east at 6 miles per hour. Now we're going to add those two vectors together, so we're going to move the current down and add it onto the end right here, and our resultant vector will be, well, the boat really travels, how fast, and the direction. So that will be right there. All right, so let's label what we know. I'm going to move that 17 over just so it's going to be easier to see. I'm going to put it right here. And so there's two ways you can solve this. You can express the vectors in their component form and then add them together, or you can use the law of cosines. I'm going to do both. So in this video, it will be using the law of cosines. If you want to see it by expressing the vectors in their component form and adding them together, it will be the other video here. Okay, so what I'm going to do now is I'm going to use this triangle that has the blue, red, and green sides there, and I have two sides of it, but I don't have an angle in that triangle. But I can see how I can get one, because basically I'm going to take this side. This is a right triangle right here, so this angle right here would have to be complementary to 68. So that's got to be 22 degrees. Well, if that's 22 degrees, then I can find this angle, because the 22 degrees and the angle in my triangle have to be supplementary. So I can take 180 degrees and subtract the 22 degrees, and that gives me 158 degrees for this angle. Now I have a triangle made up of the side, angle, side that I know, so I can use the law of cosines and I can find how long this is, and that will be the true speed of the boat. So let's do that with the law of cosines. That side squared equals the sum of the squares of the other two sides, 17 squared plus 6 squared, minus 2 times the product of those two sides times the cosine of the angle between those two sides. Okay, so x is going to be, and it says round the speed to the nearest mile per hour, so I'm going to need to do the square root of this right hand side, and that will get me x. And when I compute that, I'm going to write it to 2 decimal places for now, because I'm going to use it in another calculation. So 22.67, when you entered that one, if it says to the nearest mile per hour, we're going to put 23 miles per hour for the true speed of the boat. Okay, so this side is about 22.67. Now, the next thing I need is I need to know the direction, the bearing. All right, so as I'm looking at my picture here to see what I would want to do, well, we would need to, for the bearing, it would be this angle right here, measured off from south, headed to the east. So if I can find this little angle in the triangle there and add it to 68, I will have the bearing angle. It'll be south by that bearing angle going to the east. Well, I can find that angle in the triangle because I can use the law of sines now, since I have an angle and a side opposite a pair. So I've got sine of 158 degrees over that 22.67, so that's why I wanted to carry at least a couple extra decimal places there, and then equals the sine of that angle, we'll call it theta, that when I put the dot there, and over the side opposite that is 6. Okay, so theta is going to be approximately, calculator, and do inverse sine of 6 sine of 158 over 22.67, and it looks like that gives me about 5.69 degrees. Okay, that was the little red dot. So my angle is going to be 68 plus that. So we'll do plus 68. And so I get 73, it said to the nearest tenth, so 73.7. Okay, so this bearing is going to be south 73.7 degrees to the east.